Welcome to iBuddy Science. This is the first lesson of the chemistry unit in grade 9 science, and it's called Classification of Matter and Particle Theory of Matter. So our first topic is, what is matter? Matter is anything that has a mass and occupies space. Okay, so they have three states of matter. You have solid, liquid, and gas. In a solid state, the particles in solid matter, they don't vibrate as much, and they have lower energy, right? And hence they're more packed and uniform. In a liquid, the particles they vibrate with more energy, and they have more energy, and they're randomly arranged, and they move around more in general. And then in gas, they just move around in random directions. They're very spread out, and they have lots of energy. Okay. So let's go to this activity here. What makes these two groups different? So we have dog, we have air, we have water, we have rocks, and we have humans. On this side, we have light, magnetism, and gravity. So the main difference between these two is that this side is matter. This side is matter. And this side is not matter. Because if we go back to the definition earlier, anything that has a mass and occupies space is matter. So a dog, it occupies space, and it has a mass. So does air, so does humans, so does rocks, and so does water. However, light does not take up space, and does not have a mass. Hence, it is not a matter. And magnetism does not have a mass, does not have space, does not take up space, and so does gravity. Okay. So next topic is the particle theory of matter. First thing, it states that all matter is made up of tiny particles, and all of the particles are the same element are identical. Okay, so let's say you have a gold element and another gold element, right? These two are identical, basically. Okay, then these particles are held together by forces of attraction, and then all these particles have spaces between them. Particles are in constant motion. Particles at higher temperatures will move faster than those of lower temperatures. And that sort of ties back into our point earlier about how liquids, they have higher energy, right? They have a higher energy, and they move faster. So in liquid, the liquid particles, they move much faster, and they have more energy, right? Because when you heat up a solid, it becomes a liquid or a gas. And it becomes a liquid or a gas. You can see it becomes a liquid or a gas because the particles, essentially, they just move faster and they have more energy. And that explains why when you heat up water, for example, it evaporates into gas from a liquid. And then the sixth rule is that these particles can neither be created, destroyed, or divided into smaller particles. So let's use those theorems and the states of matter that we've learned to do these questions. So when a liquid is heated to its boiling point, it turns into vapor. So an explanation for this is that when liquids are heated, their particles move faster and have more energy. Hence, turning it into a gaseous state. So that would be the explanation for why this happens. Okay, so our next observation is that maple syrup is easier to pour at room temperature than straight out of the refrigerator. So why does this happen? If we go back to the rule here, the theory number 5, particles at higher temperatures move faster than those of lower temperatures. Hence, we can apply it straight to this question. We can say that since room temperature is high, I'm just gonna like phrase this in a very like shorthanded way, but you guys can write it more professionally in the exam. For example, since the room temperature is higher than the refrigerator, then we can say that the particles will move faster in at room temperature than fridge. Okay, which explains this whole phenomenon. Okay, our next topic is classification of matter. So we have matter right here. So anything, I'm just gonna say space and mass. Okay, so that branches off into a pure substance, or a mixture. Okay, a pure substance, and then they branch off into two different types of pure substances, which are elements and compounds. And mixtures, it branches off into two different types of mixtures: homogeneous mixtures and heterogeneous mixtures. Sorry, my spelling is astronomically bad. Okay. Yeah, I think that's mixtures here, okay? This homogeneous, they can also say solution. It's a synonym. So solution, this can also be called mechanical mixture. Okay, so let's go to what this means. Okay, two examples. Okay, I'm just gonna say two examples of elements can be copper and fluorine. Two examples of compounds, NaCl and let's say hydrofluoric acid. Okay. Two different types of homogeneous mixtures. Could be say homogeneous mixtures, salt water. That's an example. Another example can be a smoothie. We'll get through the examples later. We can get to the definitions of each of these, of what these mean, what these terms mean later. But let's go through the examples. Heterogeneous, say cookie, and I don't know, chicken soup with chicken, of course. Okay, so let's go through the definitions. Pure substance. A pure substance is essentially matter that contains only one type of particle. Okay, so a pure substance branches off to elements and compounds. So a pure substance in general is just, you have a container and you have just one type of particle, right? It could be one type of element or one type of compound. Okay, it could be one type of element or one type of compound. The only restriction to it is that in the container there's only one type of element, or one type of compound, or one type of atom in general. Okay, elements. Elements are pure substances that cannot be broken down into simple form. Okay, and they're only composed of one type of element, one type of atom. Okay, so let's say you have a jar. Let's say you have a container, and you have, let's say, full of gold. Okay, and in that there's only one type of atom in that container. There's only AU. There's only gold, right? So that means it's an element. But if you add, let's say, tin, then it's not an element, because you cannot break gold down further. But you can, let's say, you can break down NaCl. You can break down to NaCl, right? But you have AU, you have gold. You can't break down gold into anything more simple than that. Okay, so it's only one type of element in the container. Suppose. Okay, into compounds. A compound is a pure substance made of two or more different elements that are chemically combined. Right? For example, NaCl. Again, NaCl. So it satisfies that it's two different elements, right? Na and Cl. Two different elements that are chemically combined to form a product, which is NaCl. Another, and also because one last step to qualify as a compound is that in that container there's only one type of particle, because it falls under pure substances, right? A pure substance, that means that only one kind of particle is in that container. So you gotta make sure there's only NaCl in that area. So say you have container, you have NaCl. Okay, they're chemically bonded. Only NaCl. So it satisfies, yep, there's chemically two different elements combined. Boom, yes. And it's also a pure substance because there's only one type of particle, which is NaCl, in this container, so it is a compound. But for example, let's say you have NaCl and, or like, let's say another compound, H2O. These two are not in the same container. Are not, is it like each of these individually are compounds, but when you mix them together, they're not compounds anymore, because they're no longer pure substances, right? Now in this one container there's two different types of particles, NaCl and H2O. Hence it's no longer a pure substance, and hence it's not a compound anymore, even though it's made up of two different compounds, right? Okay. So even if NaCl satisfy the fact that it's chemically combined, two different elements are chemically combined, okay, NaCl and H2O both satisfy this requirement, but they don't satisfy the requirement that it's a pure substance. It doesn't like qualify as that in this container there's not one type of particle, but there's two types of particles. Hence it's not a compound, even if one of these or both of these technically qualify for this criteria. Okay, so let's go to the activity of naming if it's an element or a compound. So we can see that this first picture, so call that number 1. First picture, we see that this is clearly an element. Element. Sorry. It's an element because there's only one type of atom. So let's say this is element Z. There's only one type of Z. Okay, there's only Z. Is in this whole container. It's not like that Z plus Y to zy. Not like there's like zy here or like zy there. So it's not a compound, but it's only z, only one type of atom. So it's going to be element. So in this diagram here, this is a compound. It's a compound because we see that it is made up of two or more different types of elements chemically combined. So you have the black one, let's say that's Z, and the white one is X. So this is called, this whole thing here, this whole molecule is ZY. Okay, so there's only ZYs here, only ZYs. So it's a compound, right? Because there's only one type of particle in this container, and it's two different types of elements chemically combined. It's not like this one, where there's only Z. This one, there's both Z and Y. That's repeated. This one is only Z repeated. Okay, this is a element. Same logic there. Only this black particle is in here. This is a compound, since you see this is a element, same principle. You see that these are all green balls. Okay, this is also element. This is clearly a compound because there's two or more different. So let's say that this one is G, the green ball, this one's red. So each of these molecules are red and are GR, green and red. There's only green reds in this whole container. Hence, it's a compound. Okay, let's go to mixtures. So this is a second branch. If you go back to this slide, it is a second branch of matter. So it's not pure substances, okay? It's mixtures. Pure substances or elements or compounds are under pure substances, but they're not under mixtures. Mixtures are matter that contain more than one kind of particle. So, for example, chocolate chip cookies, right? They have the chocolate and they have the cookie part. So it's two different types of particles in the same container, that thing called a cookie, of a chocolate cookie, right? But that chocolate cookie is made up of two different types of particles. They're not combined. Heterogeneous mixtures are when different components of the mixture are identifiable and not uniform. An example is, let's say, a salad. You can identify that, oh, this is a tomato. These are avocados. These are cucumbers. This is a mixture. First of all, let's say why it's a mixture, right? It's a mixture because the avocados and tomatoes aren't chemically bonded, right? And there's different types of fruits or vegetables inside this one thing called a salad, inside this container of a salad, right? Hence, it's a mixture because this whole container contains many types of particles. There's avocado particles, there's tomato particles inside this thing, so it's called a mixture. But we have to characterize it as a heterogeneous mixture because we can clearly spot that it's a tomato, we can spot that it's an avocado, we can spot the components of it. Or let's say this, you have an oil and water mixture, you can spot the oil, spot the water, hence it's a heterogeneous mixture. So you can identify the components easily. So homogeneous mixtures are mixtures with uniform appearance and composition. So let's say a black coffee, right? It's a mixture because there's more than one type of particle. There's the sugar particles, there are coffee, there's many types of particles in it. However, it is a homogeneous mixture because you can see it's uniform. It's all black. You don't see the individual sugar grains or say the cream that's in it. You only see coffee. You only see black. The appearance is uniform, and you can't identify the individual components. Hence, it's a homogeneous mixture. Okay. So we're asked to identify the following as an element, compound, heterogeneous mixture, or a homogeneous mixture. So first of all, we know that salt is obviously a compound, right? Salt as NaCl, we talked about earlier. Pure water, obviously it's going to be an element, H2O. No, compound, sorry. It's be a compound, H2O, compound. Okay, soil, heterogeneous mixture, because you can see like the grains of the dirt and like the plants, no, the dirt and like you can, like, if you imagine a soil, you can clearly identify the components of the soil. So it's going to be heterogeneous mixture. Pure air will be a element. So pure air in this case, it means O2. So O2 is an element. Carbon dioxide gas, compound. Pure gold, element, right? Because gold is an element on the periodic table, AU. Lucky Charm cereal, heterogeneous mixture. Poppy seed dressing can be a heterogeneous mixture as well, because you can literally see the individual poppy seeds. And Lucky Charm cereal, different colors of cereal, hence you can different colors of cereal, so you can obviously say that it is a heterogeneous mixture, because you can identify that, oh, this is a looped, this is like a red piece, or this is like a blue piece. You can identify as a heterogeneous